All right, so today, this is what you've been waiting for, stoichiometry. Yes, when we have reactions taking place in solution, of course we're going to use stoichiometry to analyze what's going on in that solution. Now, when we did stoichiometry before, we used the general equation that if I go from grams of the given to moles of the given, then I'm going to cross that mole bridge, and I'm going to go to moles of the asked for, and I'm going to get to grams of the asked for. Now the difference here in what we're going to be doing is that at least one of the reactants or the products is going to be probably in grams, but the other one's going to be in solution. And so we're going to have to use the molarity definition to get moles. So I'll be jumping into the equation here, or I'll be jumping out of it here in order to calculate a volume in place of calculating grams. Let me show you what I mean by that. If you look at the sample problem for video number 5 that I gave you, let's read through that. A chemist reacts NaCl with an excess of aluminum nitrate in order to form aluminum chloride. How many liters of 0.245 molar NaCl will be needed to produce 100 grams of AlCl3? Now, I think, in fact, all of the problems in your book, Dr. Weil actually gives you the balanced equation because he is nicer than I am. And I did not give you the balanced equation here, so that's the first thing we're going to have to do. We're going to have to first figure out what the balanced equation is for this reaction. There's a lot of words in here, so let's take it a step at a time and let's figure out exactly what's going on. So a chemist reacts NaCl, so that's what I'll start with, NaCl with an excess of aluminum nitrate. So I have aluminum nitrate. Aluminum is a +3, nitrate is a -1, so I need 3 of them in order to balance. And I know that he's trying to form aluminum chloride. So Al and Cl, aluminum has a +3 charge, chlorine has a -1 charge, and so in order to make this compound balance, I've got to have a 3 there. The question doesn't tell us what else is formed, but we know there has to be something else because I haven't used up everything from the other side. So if we use what we learned in the last lesson, the aluminum and the chlorine went together to form a compound, so my sodium and my nitrate are going to go together to form a compound also. So I'm going to have the sodium, which is a +1, and the nitrate, which is a -1, so those are balanced just if I write the formula like that. Now I need to balance the equation. My sodiums are balanced right now. If I look at the chlorines, I have 1 here and I have 3 over here, so I'm going to have to put a 3 in front of the NaCl to make my chlorines balance. That throws my sodiums out of balance, so if I've got 3 here, I'm going to come put a 3 over here. So my sodiums and my chlorines are balanced. I have 1 aluminum on each side. I have 3 nitrates here, and I have 3 nitrates over here. So this is now a balanced equation, and is what's going to happen in the reaction. Now, let's start looking at the stoichiometry part of this. He tells me that I have 0.245 molar NaCl. And it says, how many liters of that am I going to need? So what I'm wondering is how many liters of that I need. I'm going to produce 100 grams of this, and this is actually in excess, okay? So that's the information that I've been given in the problem. What am I going to do with this? Well, just like we've started before, this one I can go ahead and convert it to moles. I can't do anything with this because I don't know, I know the molarity, but I don't know how many liters I have. So I don't have enough information here to get moles out of this. So I'm going to start with the 100 grams of AlCl3. So just like here, the grams of the given, put that over 1. I'm going to convert that to moles of the given. So in 1 mole of AlCl3, using your masses off the periodic table, that's going to give you 133.33 grams of AlCl3. So grams of AlCl3 will cancel out. Now I need to go from moles of my given to moles of my asked for. So moles of the given's going to go on the bottom. I need to get rid of moles of AlCl3. I'm trying to find out something about this NaCl. So I'm going to need moles of NaCl on the top. Remember that these numbers come from the balanced equation. So in front of the NaCl, I have a 3. In front of the AlCl3, there's a 1. So this cancels out. Now this is where you have to watch, because if you don't, you may end up doing extra work that you didn't need to do. I could go ahead and convert this to grams, but that's not what I need to know, because my NaCl is in solution and I'm asked for a number of liters. So I need to stop where I am right here and go ahead and calculate moles of NaCl, because then I'm going to use the molarity equation after that. So if I go ahead and calculate this, 100 divided by 133.33 times 3 will give me 2.250 moles of NaCl, because I had 4 significant figures here. Okay, so I've got 2.250 moles here. Now I can use my molarity equation to calculate how much volume of that I'm going to need. So molarity is 0.245 molar solution. I know how many moles I have, and I'm trying to find the volume. Okay, now again, watch your arithmetic, watch your algebra when you do this, so that you don't mess up and divide the wrong thing by the wrong thing. So I need to get this x off of the bottom. So what I really need to do is multiply both sides by x. If I multiply this side by x, the two of them are going to cancel out. And then I would also need to multiply this side by x. Okay, so that's going to give me x times 0.245 molar equals 2.250 moles. All right, I'm going to divide both sides by 0.245 molar. And obviously this completely cancels out, leaving me with an x over here. Molarity is moles per liter. So the moles on the top and the moles on the bottom cancels out. And I had moles per liter, so I have a liter on the bottom in the denominator. And so if you remember the rules of division of fractions, that liter flips up to the top. And so when I actually do this division, I end up with 9.18 liters of solution. And this only had 3 significant figures, so my answer only has 3. So I'm going to use 9.18 liters of that solution to make the 100 grams of aluminum chloride that I asked for. Okay, some of the problems, you will be looking for volume. Some of them you're going to start with volume, and you're going to figure out how much product you're going to make with it. The procedure's basically the same no matter which way you're going. You just need to make sure that you are concentrating on what you're doing so that you don't end up converting to grams when you don't need to, because that just makes a mess and you got to go back and fix it all. But that's why pencils have erasers.